In this lesson, we're just going to go over the binomial theorem. So I'm sure you've already come across this equation. Now, I don't want you to master it. I want you to understand where it comes from, why is it important, and then we'll look at the introduction, we'll look at the different formulas that you get to work with under the binomial expansions. Okay, so this is a binomial theorem. It simplifies the idea of you expanding two terms. So it all starts from something very small as x plus 1 to the power 2. So we already know by now that we can expand this. Okay, so we have x plus 1, and then we have another bracket for x plus 1. Okay, so it becomes very important because what if we had put this to the power, let's say the power 20, right? So are you telling me you're going to manage expanding all this, trying to show them? For you to determine the result, it's going to be a bit complicated. So that's why this came in. Of course, at this stage, we already know that if you try to expand this, you multiply x with everything in the other brackets, so that you have what? X squared, and then by 1 to give you x. You got the second stem now, again multiplied throughout with what is in the other bracket, so you have x and then a 1, which is going to reduce to what? So you have x squared plus 2x, and then you have plus 1. So that is how you perform a simple expansion. Of course, you're also able to perform, let's say, the third power. You can just add an extra one there, and after you've performed an operation, you can still multiply what you've calculated against the other bracket. Okay, well and good. So now from there, there's a simpler way of approaching it. Let's say we have lower powers. Okay, so let me just create space for what we can do. Okay, so now there's what we call the Pascal's triangle, which can also help you to perform binomial expansions easier. So this is the way it comes out. So we have a 1, it starts with a 1, and then we'll start expanding it by introducing new ones. So I'm sure you'll be able to get the trend as we move. So, and then whenever you have any number being written in between two numbers on top, you're supposed to add them. So in this case, if you had 1 plus 1, you have a 2, and then again, always at the end, you're supposed to have 1s. So a 1, now 1 plus 2, here will give me what? 3. So I'll write a 3 there, again a 3, and then a 1. So this is the way to continue going down. So I have a 1, and then I have a 4, we have a 6. So I'm just adding what is on top. So there it will be what? It will be a 4. So 6, 4, 1. Again, for another expansion, I'll add a 1, a 5, and then we'll have a 10, a 10, we'll have a 5 and a 1. Again, we'll have, let's just do one more. Then you have 1, 6, 15, 20, 15, 6, 1. So this can also, this triangle, we call it the Pascal's triangle. It can help you perform binomial expansions easier. So now let's try to do the same one that we're from doing. We said we have x plus 1, right? And then the power 2. We wish to expand that. Of course, if you're able to remember the answer that we had found, we had gotten x squared plus 2x plus 1, right? So what do you do using a Pascal's triangle? So you get the power. What power are we looking at in this case? We're looking at power 2. So this is for the first expansion. This is for the second one. So just like the numbers are telling you, so this is the second one. 2, 3, 4, and so on and so forth. So we'll go where there's a 2, which is this one, right? So I'll just write the ones. I'll write 1, and then the middle term is a 2, and then we have a 1. So I think allow me to just create some space somewhere there. So we have 1, 1, 2, and 1. So what we'll do is for the first part, we'll get what is there, x. We'll raise it the maximum power, which is what? A 2 itself. And then we'll get the other term 1. We'll raise it to the least power, 0. We always start counting from 0. And then the middle part, what is having a maximum power is supposed to start reducing. So the x, which is the power 2, is going to become the power 1. And then the 1, which is the power 0, will become the power 1. And then I'll go to the next part. X, this time around, is now going to be the power 0 because we are reducing. And then the 1 will now be the power what? The power 2. And then we are done. So if you try to expand this, Now for the first part, you're going to have x squared, because any number is the power 0 is a 1, so 1 times 1 is a 1, plus, and then the middle part is just going to have 2x, and then the other part is just going to have a 1, because x to the power 0 will give you a 1. So which proves that we are right with whatever we're doing there. And then we try to change something there. If we try to change the power, let's say we put the power, maybe let's try the power 5, right? The power 5, what you do is you just get this part. Okay, remember we are counting, so from a 2, 3, 4, 5, so get that expansion. So the basic idea, again, you start with a 1, which is there, and then you put your x. X is supposed to be the maximum power, so there's no rule there. You can start with either 1 with the maximum power, and then x starts to increase, it will still give you the same result. So, and then in the other brackets I can put a 1, the power 0. I'll move to a second coefficient, which is a 5. I'll write it, and then I'll do as wise. So x now is going to reduce to 4. 1 is going to now increase the power 1 from 0 to 1. I'll move to the next step again. The next coefficient is a 10, and then x is going to be the third power, and then we'll have what? 1 to the power 2. We'll continue moving until we get to the last coefficient, where now x will be the power 0, 1 will be the power 5. So basically this is the way binomial expansion is performed using the Pascal's triangle. Now you notice that this triangle also begins to grow. What if I ask you to find the effective expansion of the same expression? It becomes cumbersome because it becomes a little bit hard on your side, not so. Let's say we put the power 30, for example, and then they ask you to say find maybe the first 3 terms or so of that kind of an expansion. It becomes complicated. Okay, so that's why now the binomial theorem comes in to make things easier. In this tutorial, I'm just going to introduce you to the factorial notation under binomial expansions. So first of all, what factorial means is when you see n factorial. Before I can expand that, let me simplify what, let's say you have 4 factorial. What does that mean? So what that means is you need to multiply 4 decreasing all the way up to 1. That's what it means. Equally, if I get 5 factorial, it is also going to be equal to 5. I start reducing by 1 until I reach 1 itself. So 5 times 4 times 2 times 1. Okay, but all the same, I want you to know that 1 factorial itself is also equal to 1, and then 0 factorial is also equal to 1. Okay, now there are a few things that are interesting that I'd want you to get from onset. Things like if you look at 5 factorial, if you observe, you're seeing that you have 4 all the way up to 1, which is like that, which is equivalent to 4 factorial. So I can express 5 factorial to be 5 times 4 factorial. Why? Because 4 factorial is the same as 4 multiplied by the numbers less until we reach 1. That's something interesting about the factorial notation. So in other terms, how I can express this is I wouldn't be wrong if I said the 5 that we have, reduce it by 1. So I'll say 5 minus 1 and then factorial. So we do understand 5 minus 1 is what will give us what? 4 factorial. Now let's get to something more interesting than that. So from that same idea, that implies that if I've got n factorial, it is the same as n itself, and then I reduce it by what? By 1. Don't forget the factorial there. That's exactly what we did for 5 factorial. 5 factorial is the same as 5, and then we said 5 minus 1 factorial, which is 4 factorial, which is 4 times 3 times 2 times 1. We've proven that already, and we've seen that is true. Now, with that understanding, I would also want to get a bit advanced. So 5 multiplied by 5, 1. Already I've said that is the same as 5 multiplied by 4 factorial. So would I be wrong if I said it is also equal to 5 minus 1, and then I decide to subtract again a 1? So if I subtract a 1, the factorial will go, and then I'll say, now 5 minus 1 minus 1 would be 5 minus 2 factorial. Am I wrong? So in other terms, what I'm trying to say is this is the same as 5 times 4. Now 5 minus 2 is 3 factorial. So which is still true. This means 5 times 4. Now 3 factorial is the same as 3 times 2 times 1. So the one on top there, I can remove a factorial again if I want, and then I can include minus 1 again, which will be n minus 2 factorial. This is very important. You understand why I'm trying to talk about all that. Now, let me give you some ideas on what we're going to talk about next. So in the next tutorial, we'll just proceed and talk about the coefficients of a binomial. So whenever you get to say something like a and b, like that, these are the coefficients of a binomial expansion. Okay, I'm sure you've seen something like a. Anyway, let me use the actual letters that we most use. So we should use n and r. So we covered this in the introduction video. So n and r are usually the letters that we use. So what that means is, if you are taught to expand something like, let's say, a plus b to the power n, what that means is when it comes to expansions here, it will be a to the power n minus r and then b to the power r. Of course, sometimes b is our x. So I already introduced the binomial expansion, and I believe you already understood this. But if you've not, don't worry, we'll cover it in the next tutorial. Now, my focus is I want to explain what nr in the brackets mean. So that part, what it means is, or what it implies, we're just talking about combinations here. So if you have a calculator, it's n combination r. Okay. Now, trying to expand this, it is the same as n factorial over the difference of n and r, okay, factorial, and then multiply by r factorial. Okay, so if you've not gotten it, don't worry. What if we say, I'll use an example 5 and 2. Would you give it a try? So what you need to expect there is, that is the same as 5 itself factorial over the difference between 5 and 2 factorial, and then 2 factorial. Okay, that's the basic idea. That's what's happening there. So on your next step, you have 5 factorial, 5 factorial. Now 5 minus 2 factorial is the same as 3 factorial, and then you have 2 factorial there. Okay, so of course this one is very easy because you're able to expand them. How? 3 factorial is the same as 3 times 2 times 1, 2 factorial is the same as 2 times 1, 5 factorial is the same as, so let me just try to show all that so that you try to see what I'm trying to say. So 5 factorial is the same as 5 times 4 times, now remember we said it's the same as 3 factorial, right? Because we need to multiply 3 all the way up to 1 as well, 3 times 2 times 1. Now instead of doing that, you can just say 3 factorial, so that I don't need to expand the bottom part. I'll leave it as it is, so that the 3 factorial can cancel out. But don't forget that there's also a 2 factorial, which is the same as 2 times 1, which if I divide into 4 will give me a 2, giving us the answer of 10. I think that introduces some of the things that are interesting about this. So that if you're given something as big as 10 factorial and then you're given 7, you don't have to begin writing the 10 factorial, 10 times 9 times 8. That would take a lot of time and will become a bit complicated. So instead what you do is you understand that that means the 10 factorial, and then on the bottom it means 10 minus a 7 factorial, and then 7 factorial as well. So don't forget this. That's what it means. This is these are what we're now calling the binomial coefficients, which I was supposed to cover in the next video. I don't know, I found myself talking about them already in this very video. So it is well. So 10 factorial on top, we'll leave it as it is, and then 10 minus 7 will give us 3 factorial, and then we have 7 factorial. So you understand that 10 factorial is 10 all the way up to 1. Now that would take a lot of space and will be complicated. Assume calculators are not even allowed. So what you would do there, you would say 10 times 9 times 8. So I'm deliberately going to end on 7 factorial because I know 7 factorial is representing numbers 7 times 6 times 5 all the way up to 1. Why am I ending at 7? It's because I do have it on the bottom. So I don't need to simplify the 7 factorial because these can just divide. Okay? So that I'll remain with 3 factorial. Now 3 factorial can easily be expanded to be 3 times 2 times 1. So that we can divide some of these. 3 into 9 is 3. 2 into can take to 10. Okay, let me take to 8. That's 4. Okay, so 3 times 4 is 12. 12 times 10 is 120. So that's how you can easily simplify these coefficients, binomial coefficients. So you understand why it is important to talk about all this. Okay, so in the next video now, let me continue and then explain the binomial theorem now that you understand what binomial coefficients represent and what they mean. Okay, so just to ensure that you've understood the basic idea of coefficients, we'll look at just a few questions. So the first question is you need to find the value of n. Okay, so find the value of n when you have n and 4, given that it's equal to 35. Find the value of n. And then for the next one, you need to prove that n plus 2 choose 4 is equal to 6, n choose 2. Okay, and then finally for the final one, you have to prove that nr plus nr minus 1 is equal to n plus 1 choose r. You're proving that. So then for this one, I didn't mean to say prove. You're just finding the value of n for which the left and the right hand side will be equivalent. So it's the last one where we're supposed to prove. Okay, so for the first one, pause the video and just try it out to see if you understood. I'll not basically answer it, or just guide you. Okay, so hoping you've tried it out. So the way to go about it is you understand what this means. So n in the brackets there, n choose 4 means n factorial over n minus 4 factorial, and then 4 factorial, of course equal to 35. So you need to focus more on the left hand side and just try to simplify it. So the only way you can simplify this is by reducing n all the way up to n minus 4. What I mean is n minus 1 minus 1 again, minus 3 until we reach n minus 4. Okay, the reason is simple. You can't simplify n factorial in any other way. So you have n minus 4 factorial on the bottom. So at this point this will go away. So if delta with factorial, now on the bottom you remain with 4 factorial. Now this is all equal to 35. So at least it's much easier, because you're now remaining with the factorial has been dealt away with, in short. So you have n minus 1, n minus 2, n minus 3. I don't know, it seems as I've done it in a very procedural and long way, which will take some time for you to basically get to simplify all that. So we can now try to find the value of n for which the left and the right hand side are going to be equivalent. Okay, so of course for factorial, you understand what it is. That is 4 times 3 times 2 times 1. So 4 times 3 is 12, times 2 is 24. Okay, so what is it? 24. Yeah, 24. You can cross and multiply, try to, yeah, you should be able to simplify that using the polynomial expansions. Okay, so finish it up. Or maybe if I've gone in a complicated manner, you can try to comment your simplest way of solving this question. But I want to focus more on answering this one. N plus 2, choose 4, is equal to so I don't know what's happening here. So n plus 2 choose 4 is equal to 6, n choose 2. Okay, so what that means is very simple. For the left hand side, what you basically have is something like n plus 2, and then factorial of the difference, which is of course going to be n plus 2 minus 4 factorial, and then 4 factorial itself. So let's try to focus more on the left hand side for now. What basically do we have? So we have the bottom part will reduce. It will become n, 2 minus 4 is minus 2, so it will be minus 2 factorial, and then 4 factorial. So at this point, our goal is to somehow basically get to do away with the factorial. Now let's try to see what's on the other side. So on the right hand side, if you do the same, you have n factorial, and then on the bottom it will be n minus 2 factorial, and then 2 factorial. Okay, so we need to prove the left, and we need to find the value of n. Actually, we are not proving. That's where I'm getting it wrong. So 6 n factorial is there, and then n minus 2 factorial, 2 factorial. So at least we can now multiply both sides by n minus 2 factorial. So if you multiply the entire part with n minus 2 factorial, it's going to be easier. And I can also include, but let me just do that. So in such a case, this will go, that will also go. So what is remaining is n plus 2 factorial over 4 factorial. On the other side you have 6 n factorial over 2 factorial. Yeah, that's the point where we are. Now at this point it's it looks easier. So 4 factorial is the same as I can decide to expand it a bit so that we can deal with some of these things already. So 4 factorial is the same as 4 times 3. 2 times 1 is the same as just 2 factorial. So if we multiply the entire equation again by 2 factorial basically get to disappear. So what you remain with a 12. If you cross and multiply, the 12 goes the other side, so it will be 6 times 12 n factorial. Now at this point it looks easier. So what's the best way of, which one is bigger between n factorial and n plus 2? So I believe n plus 2 is bigger, so we'll reduce it. So it will be n plus 2 minus 1, it becomes n plus 1. Again we have to reduce it again. So from n plus 1 minus 1, it will just be n factorial. And then 6 times 12 is what? Do I know mathematics? 5 times 12 is 60 plus 12, 72. So 72 n factorial. Now n factorial, we've seen that it's matching up. I deliberately had to reduce 1 so that you can deal with a factorial. So we could divide it both sides. So at this point you remain with something like a quadratic function. N times n is n squared. N times 1 is n. 2 times n is 2n plus 2. 72 goes the other side, it becomes minus 72 is equal to 0. So at this point you have n squared plus 3n plus 2. 2 minus 72 is minus 70 equal to 0. So feel free to pause the video and just try out this one. So the basic idea is only consider the positive results or positive solutions. Okay, because in a quadratic function you expect to find two solutions. Now the value of n in this case is taken to be positive. Okay, so if you're using factorization method, the product there becomes 70. The sum is what is on the middle. Factors, what two numbers can you multiply to give you 70? You have, then they give you 3. So it's 10 and 7. So if they are to give me a positive 3, then 10 has to be positive and 7 as a negative value. So that you have n plus 10, n minus 7. So a positive value is obviously going to be n is equal to 7. So that's how you handle this question. Now this one is answered in the next video. So in this video we're just looking at a very interesting question. So we're proving nr being added to n choose r minus 1 is equal to n plus 1 choose r. This is a very interesting question, so pay particular attention. Let's move step by step. So if you've dealt with a binomial coefficients already, feel free to just pause this and just try it out. So I'll not use my notes, I'll try to be real so that you basically understand how you'd go about it if you find it in an exam on your own. Okay, so for the first part, we already know what that means. So that means n factorial over the difference, which is like n minus r factorial, and then of course r factorial plus n factorial over r minus 1 factorial. Now think about this. If you look at it, let's assume we want to basically get to add the two. Okay, I already explained the basic ideas about the coefficients of the factorial already, so that you basically get the concept. Now there's something that I've already forgotten of. There's a mistake I've made here. Okay, so it is the n on top minus what is on the bottom. On the bottom we have r minus 1, right? So minus r minus 1, and then of course factorial, and then r minus 1 factorial as well, just like we've done on the first part. N factorial on top, on the bottom the difference, and then also r factorial itself. Okay, thank you for that observation. So now I can simplify it to the next step. N factorial, so n factorial over n minus r factorial plus n factorial. Now if we do subtract what's in the bracket there, r will become negative, 1 will become positive. So you have n minus r plus a 1 factorial r minus 1 factorial. Now the beauty about this is, I'm sure at this point you've already observed something common, right? You've observed something common about what we have. If you check the first two brackets, they are deleted in a certain way. The one on the right is just one higher than the other. And then again, if you compare r and r minus 1, one is just higher, right, by 1. So r itself is higher. R minus 1 is less by a 1. So we can somehow expand the bigger ones so that they can showcase the other one. What I mean by that is, we'll apply this. We know that let me start with r. R is bigger than r minus 1. Okay, so I can expand the bigger one, which is r. So r factorial, let me use a different color there. So r factorial is basically equal to, I can expand it by reducing it by 1, r minus 1 factorial. And then this one is bigger by a 1. I can also say n minus r plus 1 factorial is also equal to n minus r itself plus a 1. If I reduce it by a 1, it will give us what? It will give us, the 1 is going to disappear, so it will be n minus r factorial. So you understand why I've done all that. So I'll leave the top part. So I'll expand. So we have n factorial over, now why there's r factorial, we'll put that. So we'll maintain n minus r. Now we said r factorial is bigger, so it is, we can expand it as r minus 1 factorial plus the other side, n factorial is to be maintained on top. Now this part has been expanded. Okay, so it's equal to n minus r plus 1, and then if you reduce it by 1, it gives you just n minus r factorial. And then don't forget you have r minus 1 appearing as well. So I've just substituted on the part where I've got r and the part where we have n minus r plus 1. We've expanded them by reducing by 1, just like we said. if you have 7 factorial, it is the same as 7 times 7 minus 1 factorial, which is of course 6 factorial. Okay, so we're just using the binomial coefficients principles. I meant to say factorial notations. At this point, we can factorize something, that is the things that we can notice that they're common. I can see on top we have n factorial is common. On the bottom, what do you think is common? I can see this part is common. That's the reason why we're expanding, to come up with some common terms. And then I can see r minus 1 factorial is also common. So we'll start with n minus r factorial, and then we have r minus 1 factorial. Those are the two things that are common on the bottom. Then on top, of course, we've already factorized n factorial, so we have a 1 for the first part. So for the first part, if you are to remove these from the bottom, what only remains is r plus. For the other part, if you remove the other two, only this part, only that guy will remain. So it's 1 n minus r plus a 1. Okay, so we've just like dealt with that guy. So at this point, we can try to simplify what is in the brackets. Okay, so of course we understand we need to come up with a common denominator and all that. So what's a common denominator if we were to look at the two there? So we have r multiplied by n minus r plus 1. Okay, so what's standing out on top? So r into this, we just get n minus r plus 1, and then if you divide that, you get r, so plus r. So you're noticing that on top the r will cancel out, so that you remain with n plus 1 over r, and then multiply by n minus r plus 1. Now at this point, things have started making sense. At least we can see that the n plus 1 has appeared, but we are not yet there. So in the brackets, we've already simplified that. So hoping on your paper you would have gone on the next step. So I'll just substitute that for the sake of simplicity. So we have n plus 1 over r n minus r plus 1, after adding what had remained in the brackets after factorization. So then I can move this a bit up, so that we can try to see if we can simplify it further. Okay, so I'm trying to simplify this to what is, of course, to just give you an idea, the right answer there is expected to be something like this. Right hand side is expected to be, of course, it is n plus 1 r. So applying the same concept, it's supposed to be n plus 1 factorial over n plus 1 minus the r factorial, and then r factorial. So that's our goal. Now for our left hand side, at the point where we've reached right now, what can we do? So n factorial times n plus 1. Think about it. Be smart about it. You have n plus 1 in brackets multiplied by n factorial. What can you observe? Now n factorial, or n, is just less if you compare to n plus 1. So if you combine the two, they are equal to n plus 1 factorial, because I can use n plus 1 by 1, which will give me n. What I'm trying to say is 7 times 6 factorial is the same as 7 factorial. So on the top part, if you want on your paper on the next step, you can even show, you say n plus 1 in brackets multiplied by n factorial. denominator equal, you have to be smart about it. So what we have on the denominator part, so I've got r multiplying by r minus 1 divided by a tree as well, and then the other part as well, divided by a tree, we have n minus r plus a 1 multiplied by n minus r factorial, also divided by a tree, grouped together. That should be equal to, now the top part I've already shown you to say if you combine them, get the bigger one, so n plus 1 factorial. The denominator part, if you compare r and r minus 1, r is just less by a 1, so again if you combine them, it just be r factorial, and then this other one, this is greater by 1 as well, so if you reduce by 1, it goes to that, so you can also just get the bigger one, which is like n minus r plus 1 factorial. So at this point, on the next step, just arrange them properly, okay? But all in all, the top part is matching up, and then it's just that the r can go just, which is of course multiplication is commutative, it doesn't matter where you've placed it, and then inside there, negative r and positive 1 can just be exchanged. That's still the same. So on your conclusion, you can say since the left hand side is equivalent to the right hand side, and it's proven that that is basically true. So we've just used the with an understanding of our binomial coefficients and the factorial notations to basically get to that result. Let's now talk about the binomial theorem in very, very simple terms. So what do we know about the binomial theorem? So the basic idea is this: the coefficients that we've already talked about, n0, n1, all that. So in a case where they want you to expand, we use a plus x in brackets, let's set the power n. Okay, the way you basically get to expand that is you start the binomial coefficients from n choose 0. So n choose 0, and then the first part, the other part will always be including a and x, so it will be a and x. Now their powers are to be dependent on the values in the brackets. What I mean by that is, in this case, your a is going to be the difference between n and 0, which is just like n minus 0, which is just like n. For x, it will be x to the power 0. For the other part, the second part will be now n, you now choose a 1. So if you choose a 1, your a will be the power. Now a will always be like the power difference between n and r, so it will be n minus 1, and then x will always be matching up with the value of r on the bottom there. Try to guess what will be the next term there. So it will be n choose 2, a will be to what power? Now a will be now the difference, which is n minus 2, x will still match up with 2. Try to guess the other term, n choose 3, a will be the power difference, then b, which is x, will just match up with 3 again to the power 3, and so on and so forth. That's basically the binomial theorem. So it's just built on the main idea of you working with the issues of the binomial coefficients. Now you understand what the binomial coefficients are, so each time you'll be counting in that way. Now I've already explained, actually in the next video I will explain how you basically get to find the specific nth term. For now, this is the basic idea about the binomial theorem. Okay, so how basically do we use this expansion? Now, of course, earlier on we saw that we can use Pascal's triangle to deal with simple expansions like 2 plus x. Let's set the power 2, even up the power 3. It's very easy for you to basically expand that. Now, I'll use a simple one to the power 2, which you're able to expand without any need of binomial theorem. So you know that that's the same as 2 plus x. 2 plus x. So if you try to expand that to simplify it, 2 times 2 is 4. Of course, you have x squared plus 4x, I believe, plus 4. Now, how would you handle that using the binomial theorem? So for the binomial theorem, remember in this case our a is 2, our x is our b. So our power is n. So when it comes to the binomial theorem, you say your n is 2, and then of course always start from 0. So 2 choose 0. What are we going to have? So we're going to have the first part, which is our a, is our 2 there. Okay, it's our 2. So it will be 2. Now I said it is going to be the difference between what you have in the what you have as your binomial coefficients. So 2 minus 0 is just going to be 2. And then your b in this case is x itself. So x will be the power 0 plus. It will now be 2 choose 1. 2 will be the power. It will now be the difference. Again, 2 minus 1 is a 1. X will match up to 1. And then we have 2 choose 2. 2 minus 2 is 0. X will still match up with a 2. So I've already made the relation to say x will always be matching up with what is on the bottom in your coefficients, as you can see. And then the a part, which in this case is a 2, will always be the difference between what is inside there. 2 minus 0 is a 2. 2 minus 1 is a 1. 2 minus 2 is a 0. That's the basic idea. Now, of course, you know how to simplify what is in the brackets, right? But what I mean by that is the binomial coefficients. 2 choose 0 is the same as 2 factorial over 2 minus 0, which is as of course 2 factorial, and then 0 factorial. I already explained to say 0 factorial is equal to a 1. So these will just divide, giving us a 1. 2 times 2 to the power 2 is a 4. X to the power 0 is just a 1. So for the first part, the answer is just a 4. So this explains one concept which I'm yet to explain. Whenever you have got 2 choose 0 or any number choose 0, the answer will always be equal to a 1. Okay. X to the power 0 is also equal to a 1. So you just have a 4. Plus 2 choose 1 is 2 factorial over 2 minus 1 factorial, 1 factorial. 2 minus 1 is a 1. So on the bottom you just have a 1. On top 2 factorial. So this explains why whenever you've got any value and then you have a 1 on the bottom, it's always going to be equal to n factorial. To always be equal to n factorial, I believe. Is it n factorial? And we'll try it. I hope I'm right. If not equal to... No, it's always going to be equal to n or c. Yeah. So we have 2 factorial, which is of course in this case is just equal to a 2 times 2. 2 to the power n is 2, so it will be 4x. And then for the last part, 2 choose 2 is the same as 2 factorial. 2 minus 2 is 0 factorial, and then 2 factorial. This also becomes equal to a 1. It always be equal to 1. So we have 1 times 2 to the power 0 is a 1 as well, so you just have like x squared. So this guy is matching up with that part. Okay, so that's the way the binomial theorem basically works when it comes to expansions. Now there are three different things that I need to make mention of and explain them so that we can simplify the binomial theorem unlike the way we have it, because at the moment the way it is looking, it is appearing as n choose 0, a will be the power n minus 0, which is just like n, and then x will be the power just like 0, and then you have n1, a will be the difference, x will be the power 1, and so on and so forth. And then at the last point you should choose n out of n, and then a will now be n minus n, which is like 0, and then x to the power n, like that. Okay, so how do we handle this? We want to simplify this more than we have it right now. So what I'm trying to say is, if you look at n choose 0, that is the same as n factorial, and then the difference is n minus 0 factorial, 0 factorial. So that is the same as n factorial. N minus 0 on the bottom is just n factorial. 0 factorial is just a 1. So this will always be equal to a 1. So any value of n choose 0, or any value combination 0, it is just always going to be equal to a 1. Okay, now I want you to take note of that. So that is always going to be equal to a 1. Now the other part I want to talk about is n choose 1. This is the same as n factorial, n minus 1 factorial, and then 1 factorial. Of course 1 factorial is just equal to 1, so you have n. Now you can simplify that. It will be now n minus 1 factorial, so that it can cancel out with the n minus 1 factorial on the bottom. So any value of n choose 1 will always be equal to n. And then finally, when you have n choose n, it becomes n factorial. N minus n is just like 0 factorial, and then n factorial, n minus n, and then n factorial itself. So you notice something as well there, that will always be equal to 1. So n0 and n choose n itself will always be equal to 1. So these are the three things that I want you to know. So they are going to reduce or simplify our expansion in this way. You are going to have so n choose 0 is 1. So this will no need of writing that each time you're expanding. And then x to the power 0 is always going to be a 1. So that's why if you check some textbooks, the expansion comes out this way. It is a to the power n plus. For n choose 1, you just see n. Okay, it's not necessary to show n choose 1 because it's always going to be equal to n. And then you have a n minus 1 x to the power 1 plus. At this point now, that's where it now becomes necessary for you to begin choosing now. N choose 2, a to the power n minus 2, x to the power 2, and so on and so forth. And then of course for the last one, it just, that is equal to 1, that is equal to 1, so it will end up with x to the power n as well. So that is the simplified form of the binomial theorem. Of course, in the next video I'll talk about the case where instead of having a, you get to have 1 plus x to the power n. Okay, how does that affect that binomial theorem? So usually that deals with the negative and the rationals. Okay, but anyway, we'll talk about that a bit later actually, because we have to talk about the certain practice questions that we might expect, things like the terms independent of x and how to deal with other things as well. Okay, so we now know what the binomial theorem is, and the easiest way to remember, I believe you've gotten it. Now, just for the sake of practice, let's say we use the same question I gave you. Okay, the part 10, right? So look at this question. So let's try to find a few terms of this. Let's try to expand this. So the way we're going to expand this is, now I never wanted to deal with the one where the value of a is equal to 1. Okay, let me deal with this one. Let's say we have 2y, 2x, okay, 2y plus x, let's say the power 3, and then you're told to expand that. How do you go about it? So using the binomial theorem, you can go take your a to be 2y. So in this case, it will just be 2y. The power itself is 3 plus our n is 3. Our a is 2y. Now, as you basically get to notice, as you get to be conversant with this, you'll be able to see that your value of n is reducing by 1 at each point. Okay, so 3 minus 1 is just a 2. X begins to increase. Okay, plus. Now, this is now where you'll be introducing the binomial coefficients. Your n is 3. You are choosing a 2. And then you have a. Your a is still what? 2y. Now at this point it is raised to the power 3 minus 2, which is now just like 1. And then your x will match up to be the power 2. And then for the last part you have 3 choose 3, which I already explained that is just the same as just like a 1, but I will just show it for the sake of your understanding. And then 2y will be the power 0, and then x will be the power 3. So for the sake of your understanding, again I can introduce in all the other terms. There's no restriction. So for the first one, it is always going to be choose 0. For the second one, it will be choose 1. Okay, which is 3 choose 1. And then of course x will match up with the value of r. So that's basically the way the expansion works. Now of course, with some of the things that I've taught you and I've already explained, instead of doing or showing all that, you can just simplify your work, because you know 3 choose 0, it will always be equal to a 1 in respect to the value of n. Now 2 to the power 3 is 8, so you have 8y to the power 3. X to the power 0 is always going to be a 1, so not necessary to be shown, plus the second part where we've got 3 choose 1, it's always going to be a value of n, in this case which is a 3 itself. 2 to the power 2 is 4, so you have 4y squared x. You continue like that. 3 choose 2. Okay, so I also didn't talk about that. Whenever you're choosing something less by a 1, I believe it should just be 3 itself. So 3 factorial is 3 minus 2 factorial 2 factorial. So your answer will be 3. So you have a 3, 2y x squared, and then for the final part, that is equal to a 1, 2y is equal to 1, you just have x to the power 3. So of course that becomes 12y squared x. This becomes 6yx squared. So that's basically the way you basically get to deal with the binomial theorem when it comes to dealing with expansions. Okay, of course there will always be other things where it will be a bit difficult for you to simplify everything and expand and do whatnot, but basically we'll talk about the other forms of questions that you can handle. But all in all, with practice, this will not be difficult for you to remember that in a case where you have a plus x to the power n. Always start with n choose 0, and then a will be the difference of what is in the coefficients, and then x will always match up with a value on the bottom. Okay, so again a will be the difference, and then x will match up with the bottom, like that. You continue like that. Okay, so you continue until you reach n choose n. That's the binomial theorem. Okay, so for the sake of your practice, I want you to deal with this question: 2x plus 1 over x to the power 10. I want you to find or expand up to, let's say, first 6 terms. Okay, show the first 6 terms of that expansion. So you start from 10 choose 0 all the way up to 10 choose 5. That's fine. Okay, so that would be a good start for you. Previously we've talked about the idea of dealing with the binomial expansions using the binomial theorem. Now, how can you directly find the nth term? What that means is, let's say you have 2x plus y, let's say the power 10. Now let's say they ask you to find, for example, the 6th term. How do you do it without necessarily expanding everything from like n0 all the way up to like n5? Of course, why am I saying n5? It's because we understand that the first term begins with a 0 there, so we end with 5 if we are trying to find the 6th term. So each time they ask you to find the value of the nth term, r is going to be less by a 1. So that means if I ask you to find the 100th term, know that the value of r on the bottom is going to be 99. Okay, so how do you do that without having to expand everything? So I've already given you like a tip. So n minus nr as your binomial coefficient, and then if you have a plus b, which are usually what we use to represent, let's say, the power n, so your a is going to be the power n minus r, and then your b just to power r. I believe you're now getting conversant with this expression. Okay, let me try to give you in form of a number so that maybe you can get it again. 4, and let's say you add a 4 and a 1. When it comes to the expansion there, it's going to be your a that you have, the power 4 minus 1, and then your b is just going to be the power 1. So it's like the b part matches the up with r, and then the a part is the difference of the two. I think that will help you to remember if you've not yet gotten hold of that. Okay, so with that understanding, I've said the value of r is always going to be less by a 1. So if I've asked you to find the 6th term, what do we expect to do? So your value of n is going to be what the expression is raised to. So in this case, our value of n is 10. So you have 10. Your value of r is going to be less by a 1. So 6 is a 6th term. So minus 1 gives us a 5. What I'm trying to say is r is equal to n minus 1, because we start from 0. So if you move there 10, 5, now our a in this case is 2x, so say 2x,
n minus r. What does n minus r mean? We say the difference between 10 and 5, so it will be 10 minus 5, and then b in this case is our y. Now y is going to be raised to the power r, which is 5 in this case. Okay, so at this point I understand it's not a struggle for you to basically simplify that, because I've already explained what 10 choose 5 mean, or 10 combination 5. So if calculators are allowed, that's even easier for you. But in case where calculators are not allowed, we said it's 10 factorial over the difference 10 minus 5 factorial and then 5 factorial. 2x 10 minus 5 is just going to be 2x to the power 5 and then y to the power 5. Okay, let's see what we're going to have. So at this point we have 10 factorial, so the highest value we have on the bottom is 5 factorial, so I'll reduce 10 all the way up to 5 factorial, which would be like 10 times 9 times 8 times 7 times 6 times 5. 5 factorial. 5 factorial is representing the numbers all the way up to 5, their product. So 10 minus 5 is also 5 factorial, 5 factorial. So one of the 5 factorials is going to cancel out or divide, in other terms. So 5 factorial can be expanded since we can't cancel it with anything. I'm just trying to give you ideas on what you need to do in cases you had such expressions without calculators being allowed. So 5, there it gives us a 2. 4, there it gives us a 2. 3, there it gives us a 3. 2, there it gives us a 3. I hope all my calculations are okay. So 3 times 2 is a 6. 3 times 2 is a 6. Okay, so what are we remaining with now? 6 times 6, 36. Now we have 36 times 7. So 36 times 7. 6 times 6 is 36. 36 plus 6 is 42. So 7 times 6 is 42. So you write a 2, carry a 4. 7 by 3 is 21 plus 4, 25. So 252. I hope I'm right. There are videos where I've made mistakes with such calculations. 2 to the power 5 is the same as 2 times 2 times 2 times 2, 5 times. 2 times 2 is a 4, times 2 is 8, times 2 is 16, times 2 is 32. 2 times 2, 4, times 2, 8, 16, 32. So we have multiply by 32, x to the power 5, y to the power 5. So you can multiply your 32 and 252. You'll be able to get your final solution. So this is just like an introduction to how you go about finding the nth term. Now for the sake of your practice, I want you to try out this one and then just like be willing to share the solution with the tutors or in the comment section. 1 plus y over 3, okay, and then raised to the power 10. I want you to find the 6th. Again, not the 6th this time around. Let me find the 8th term in that expansion. Find the 8th term in that expansion. So that is your understanding. Try to see if you've understood how to go about finding the nth term. It's very important, even as you basically get to do your personal studies, that you practice before you move on to a new concept. So previously we've talked about the binomial theorem. We've also talked about how to find the nth term. So I want us to practice what we've learned so far. So using the binomial theorem, we need to expand. We can expand given expressions. For example, that one, understand that since it is raised to the power 12, you start with 12, choose 0, and then your a in this case is 2x, so it will be the power 12 minus 0, which is just 12, and then negative y will be the power 0. So one thing that we've learned so far is the fact that as you are expanding, the first part, which in this case is 2x, will always be the difference of the coefficients, and then the b part, which is negative y in this case, will always match up with the bottom coefficient, as I've shown there. So when you have 12 choose 2, 2x will be the difference, 12 minus 2, and then negative y will just still be the power 2. It will just always be matching up with the bottom power. Now, certain things have already been established. The fact that when you have 12 choose 0 is equal to 1, when you have 12 choose 1 is equal to 12, and then 12 choose 12, if we add it, it is also going to be equal to 1. So these things have already been established. So that's it about the binomial theorem. Now I want us to answer these questions. We need to write and simplify the indicated term in the expansions of the following. So we also need to find the 15th term in that expansion, and this will introduce us to a new concept where we need to find the term independent of x. Okay. So 7th term. So we've already established to say when you have n and r, from what I was trying to show you, given that you have a plus, let's say x, in your expansion, the basic idea there is what you ought to do is your a will be the difference, as I've said, and then your x will always match up with the bottom power. We've already established that. So that is what we're going to be using when it comes to finding the term. So when they say find the 7th term, what that means is your r is going to be less than by 1, because we start counting from 0. So if you start counting from your 0 as your 1, you end up at 6 as your 7th term. So your 7th term, the value of r is always going to be less than a 1 from n. So therefore, in this case, when they say find the 7th term, what we're going to have is we're going to have our value of n, which is 12. We are choosing 6 because we start from 0. So therefore, our a in this case has been given to be 2x. It will be the power 12 minus 6, and then x, which is our y in this case, negative y, that is, will be the power, the bottom power, which is 6. So we have 12 choose 6, which if you have a calculator is 12 combination 6. So 12 factorial over 12 minus 6 factorial, 6 factorial. Then you have your 2x being the power 6, and then negative y being the power 6. So whenever you raise a negative number or variable, it's going to be to an even power, it is going to be positive. So of course, for the sake of simplifications, for a 12 factorial there, you remain with 12 times 11 times 10 times 9 times 8 times 7. The 6 factorial will just cancel out with that, and then of course you still remain in the 6 factorial in 12 minus 6, which will be 6 times 5 times 4 times 3 times 2 times 1. 2 to the power 6, I believe that should be 64, if I'm not mistaken. 2 to the power 4 is 16, 2 times 2, yeah, 16. So 64 x to the power 6, y to the power 6. So you can try to simplify this. Let me just guide you. 6 into 12 is 2, 5 into 10 is 2, 4 into 8 is 2, 3 into 9 is 3, 2 into 1 2, it will just be a 1, and then at least, so what you have on top is 2 times 3 times 2 times 7, which is easier to deal with, right? And then you multiply that by 64, you'll be able to get the coefficient. But all in all, my focus was on trying to show you how you basically get to find the term, and of course remind you of what we know so far. So with that very concept, you can answer the second one, right? The ninth term. So the ninth term, what would be the expected value of r? So it would be 15 choose 8. Your a is your 2, and then your x or your b is x over 2. So what did we say? So we said for your a part, it will always be the difference. So it will be 15 minus 8. Then the other one will always be matching up with what is on the bottom, right? So that's for B. Now let me focus on the remaining 3. So we need to find the middle term of this expansion. So of course the half of 10 is 5. But if you want to make more sense, if you write 0 all the way up to 10, 0, 1, 2, 3, 4 are the first 5 numbers, and then 10, 9, 8, 7, 6 are the last 5 numbers. So what is on the middle is 5. So your value of r is 5, and that's what will help you find the middle term. So in short, what you're trying to find is just 10 choose 5. Your a is known to be 2, your b is known to be 3 over x. So 2 will be raised to the power 10 minus 5, 3 over x will be raised to the power 5. We've already talked about that, we've already established that from that formula on top. So you're able to simplify C. Now, very interesting are the last 2 on this page. These are the ones I want to focus more on. Hopefully, if you're tired, please feel free to pause, because I did want you to get this, because this is a very, very important concept under binomial expansions. Excuse me. Let me drink some water. I've been talking for so long now. Okay. We have to find the term involving x to the power 5. This is something very interesting. So it would be easy if you, of course, that question was based on the first 3. Okay, so you should be able to predict, by the way. So if, for example, let's say it was applying to question 1, I would just guess to say, okay, if 2x is like my first term, right? If I want to get a point where I will have, because what I'm saying here is, I want to get a point where it will be to the power, where x will be to the power 5, where x will be to the power 5. So if I can substitute, I would say, okay, I have 12, and then my r, I don't know, because that's the term I'm trying to find. And then your a is 2x. So I'll focus on the part where it's 2x. Now your n is 12 minus r. So what I'm trying to do is I'm trying to find a case where the power will be equal to 5. So I'll just say, when can be 12 minus r be equal to 5? So 12 minus 5 is equal to r. So your r becomes equal when the value is 7. So in terms of the nth term, it's the 80th term. That's the one that is going to give us what? That possibility. Let's try to see now. Let's try to apply that to the question at hand, which is D. It's a bit interesting because we have x on the bottom and also on top. So let's try to handle a question where we try to find the term independent of x. Of course, this one that we have, we'll try first of all by trying to find the 15th term, as the question requires us to. So n choose r, we expect that if you have a plus x, it will be a n minus r, and then for your b to just be the power r. So in this case, our value of n is 20, and we don't know what term, if the term is 15th term. So if we're dealing 15th term, the value of r will be less since we start from 0. So therefore we have 14 as our 15th term. And then our a is x, n, our n is 20, so it will be 20 minus 14. And then our b is negative 1 over 2 x to the power 14. So feel free to pause the video and just try to see if you're able to remember the binomial theorem in a case where you have your value of a being equal to 1 to the power n. So what is a general formula? So obviously we've come up with a formula to say you have 1. You can finish it up and then resume. So we have 1 plus n of x plus, so of course the first part is n choose 0, n choose 1, n choose 0, n choose 1, so it will be n choose 2. So n choose 2 go all the way up to n minus 1, 2 factorial x squared plus n minus 1 all the way up to n minus 2, and then 3 factorial, that means x will be to the power 3, and so on and so forth. So that's the general formula for that form. Okay, so then let's try to simplify a case where we have a fraction. Let's say 1 plus x to the power 1 over 2. How do we answer such a question? Well, we'll continue by now looking at how we use binomial theorem to determine the square roots of imperfect squares. Of course, how do you find the square root of 17 is the example that we're going to work with. Okay, so with that example, you should be able to answer all these simple questions like finding the square root of 5, finding the square root of, so instead of even just finding the square root, you should also be able to find, let's say, the fourth root of 17 and all that. So how basically do we handle this using the binomial theorem? I've got some good interesting questions about to make sure that we've understood the concepts of binomial expansion in the form of 1 plus x to the power n. So question 1 says, in the binomial expansion of 1 plus bx to the power negative 5, the coefficient of x is negative 15. Find the value of constant b and the coefficient of x squared. The other one says, write down the first 4 terms of a binomial expansion of 1 over 4 plus 3x to the power 2, stating the range of values of x for which the expansion is valid. So this is the other one. Feel free to try it out as well. Let's go back to the first question. So before I actually get to answer these questions, there are a few things that I feel are very important for us to review before we actually begin answering. So let's say you've been given 1.01 raised to the power negative 2. These questions usually come where they, for example, give you a question, right? They say they want you to expand 1 plus x to the power n. Let's say they say all the way up to x to the power 3. So you notice that as you expand that, your result will be something that will look like this: 1 plus nx plus n minus 1 and all that, right? So actually I've just written the formula. Now let's say you've already substituted in the value of n. Possibly the value of n will be given to be the same one, let's say negative 2. So you've already computed that. So, and then they ask you to say n's approximate the value of that. How do you handle such a question? So the way you handle, so we basically get to approach these questions using the concept of 1 plus x to the power n, kind of an expansion. So we've got this set of questions, we've got this, and then we've got this one as well. Compute each of the following. Now it becomes interesting. Well, if you look at it in terms of fractions, let's say 1 plus x to the power 1 over 2. So you can pause the video and just try that one out. And then you can also have 1 plus x raised to the power negative 2. How do you also handle that? So one thing that you're going to notice that this will lead to what we're calling now series, in a sense that you will never get to a point where you say half choose, where it becomes half out of half. And actually it doesn't make sense to have that half doesn't make sense. So what you notice is that's why it was necessary for us now to have a formula in that case, where we don't have to work with the combinations, but instead we just be substituting the values of n. Okay, so we'll continue from there.